How you going, guys? Today's video, one of my favourite, is 996. So I'm going to go do a bit of an overview on 996s, go through the hydraulic circuits, basically all the systems in it. I've spent a lot of time working on the 996s over the years. It's a 600-tonne excavator. I've pretty much done every major component can change out in any sort of configuration, so I'm pretty excited for this one because yeah, I've done a lot of breakdowns, a lot of change out work. I've probably spent the last 9 years on and off working on them, and then probably 4 of those years fairly solid predominantly on 996s and 9350s. So still learning every day on them, and yeah, basically yeah, thanks very much for the support on the last couple of videos. It's been amazing. So yeah, thanks heaps. 10K on Insta, TikTok, Facebook as well too. So leave me a comment, a constructive one, and smash the like button for me. It really helps the algorithm to get my videos out there, and then I'll give me the justification to punch out more. So we're really getting some traction on the YouTube. So I'm going to go in depth on the hydraulic circuits, give you some explanations, some of the electrical systems that are in it, and hang around to, I've got a heap of failure videos that I have in my archives that I'll go through and give you some explanations on them. So that's really fun, that sort of stuff. So basically the 996 is a 600-tonne mining excavator. Basically they've been now superseded by the 9600. Haven't done a whole heap on those, but from what I see, they have pretty much all the shortfalls that the 996s have, they've rectified with the 9600 in performance and in workability as well too. So they are known to be notoriously difficult to work on, so a lot of people complain about it. Operators seem to love them though, and they're a staple here in the Pilbara in Australia. There's quite a few sites that are still running them, and they're coming to the end of their life. But as you know, the demand on machines and getting them to Australia, they just keep running, so they'll just keep rebuilding them and maintaining them, and it's good to see there's not many places though that really do run them anymore. They are starting to come to the end of that, and the 9600 is starting to take over, and justifiably so. They're an amazing bit of kit. From the small experience I have on those 9600s, they're a phenomenal machine. So yeah, hang around, let's go. So first up, I'm going to go through the engine layout. It's a east-west layout, super reliable K50, so it's twin engine. Basically belt-driven fans on these ones, always a terrible job. You really need a skinny guy to sneak in there sometimes to get the belts on, but you can also do the belts from the front of the engine by dropping it down, the fan hub down on it. So that's a notoriously difficult job, and they're difficult to bar over with you have what they call hockey stick hoses that come down, and makes it very difficult to bar those engine over, but super reliable. If you don't change the injectors out, unfortunately, for the life of that engine, you tend to get what they have a fault manufactured into the push rod, so it doesn't destroy the camshaft. And dead giveaway for that is white smoke when you're going down to the machine, coming out of one stack, and they will run for quite a while with a snapped push rod in one of the cylinders. So moving into the pump room, we have 2 splitters, so obviously 1 per power pack. We have 4 main pumps per engine. These do tramming and attachment. We have 1 hydraulic fan per power pack. We have 2 swing pumps per power pack. Track tension up the front of the engine there. We have AC pump there as well. 2 charge pumps, that's for your slew circuit because it's closed loop slew. We have 1 servo pump, 1 spline lube, 1 splitter lube for each engine, right? So moving into the pump room again, we're going to the SU1 block, and basically this is like the logic block for your pumps. It contains the servo relief up in there for each engine, so I have 1 block per engine. We have our Y3s and Y4s in there. So Y3s, they split the pumps up, so pumps 1 and 3 stroke together, and 2 and 4 stroke together, right? So that is 1 and 3 does tramming. Moving on, Y10, that's what strokes our hydraulic fan pumps, and yeah, basically that is like the logic block. You have 2 Y4s on this, so if you have 1 Y4 that fails, you can then move the line from one to the other, right? Then for our TCV, which is our torque control valve for our swing circuit. We have one of those up in each pump room as well too, so pretty nifty closed loop slew circuit on this one. You have the Y151 and Y155 and YRs as well too, so that's what does your left and right slew that basically shuttles your counterbalance valve across, and you have a max pressure valve in there as well. With that max pressure valve, they have check valves in the pumps, so when you're slewing to the right, obviously you've got a higher pressure going back up to your TCV, so they use a shuttle valve in there to shut the higher side off from the lower side, so the higher side's going to your max pressure, or what's called a limiting valve, right? So the way they do things on these swing circuits is, I've only recently found this out from Cody from Liebherr that I used to work with. Thanks, Cody. Basically, so the TCV on Power Pack 1 controls the pump on Power Pack 2. I always knew that, but I didn't know the reason behind it, right? So what they do is they stroke pump 1 and pump 2 on Power Pack 2 together, and then vice versa for the other Power Pack. Reason being is when you're running single engine operation, you stroke one pump up, puts that pump in a high flow, low torque state, and that is what prevents the engines from turning over, right? On the ONKs, they utilise what's called blocking valves, right? So that's the pump room. So moving on into our valve bank area, right? We have 4 valve banks. So main pump 1 goes to valve bank 1, main pump 2, valve bank 2, 3 to 4, 3 to 3, and then 4 to 4. And so each engine has one pump that goes to one valve bank, right? And the reason being is 1 and 3, like I said, the pumps stroke together on either power pack. This is what does your tramming, right? So 1 and 3, valve bank 1 and 3 contains our travel spools. So monoblocks on top of the boom, so they've got a remote housed secondaries up on our monoblocks, right? And they have the travel ones housed in the travel secondaries housed in the valve bank itself, and you have your main reliefs housed in there as well. So under the valve bank 1, we have our servo control proportionals. So basically when you put your S7 lock lever down, it powers up the proportional block and then sends servo oil off to all our Ys and YRs. So our Ys and YRs are what does, for either direction of your spool, and activates the servo oil and sends it to your spool caps, right? You have your travel brake proportionals down there, and your swing brake, so on, right? Basically, so the Ys and the YRs are utilised. The FSG board up in the cab is what determines the logic when you interpret operated demand. It's what gives you your priorities. So basically 4 proportionals, Ys and YRs will power up for boom up, but then when you pull a breakout implement, stick or bucket, it will drop valve banks away accordingly from the boom and give priority flow to your breakout implement, and vice versa with the tramming. So that's all done via logic. I feel like it's a fantastic layout, and I feel like my experience over the years with the ONKs, love them, but the Liebherrs with this system just seem to have that advantage over the ONKs. They split their flow from their pumps up much better, right? So in the same area we have 4 swing boxes and swing motors. Basically crossover hoses on those, we know about those. They equalise the flow, so because no 2 pump and no 2 motor is made the same. Notoriously difficult jobs, especially the rear ones, and if you don't keep that centre girder area clean of grease, because there's a massive build-up of grease in there, they're terrible job. We also have our under engine hoses that come through there up to our valve banks. That is another notoriously difficult job, and then when those hoses blow, makes a massive mess, right? So valve bank area, it's the hard pipes on the opposite side as well too are very difficult to access, and sometimes you might find yourself, if you get one that splits, you'll be pulling 3 or 4 pipes out to get just one out. So they are a difficult job, especially when the machine's hot, and it's very difficult to get up to your mounting bolts for those hard pipes as well too. So yeah, so we have a super reliable grease system in this one. We have 3 pumps, one's for attachment, one's for slew boxes, they grease the bearing, and then we have one for the slew bearing itself. So the slew bearing one has a B150 and B150.2. Basically this is what actuates, it has a little actuator on there to tell that it has enough shots of grease, right? Basically There's a controller in the cab there where you can manually cycle the grease, and it also has servo oil on that screen, so the grease pumps themselves run off servo oil. So some giveaways for the attachment that you have leaks and failures in that system is that you will get excessive buildup of grease on one. So the Liebherrs, unlike the O&Ks, are not a notoriously greasy machine, but if you do get a machine that pulls up for service or pulls up for inspections or whatever, and you have grease dripping off it and a really greasy area, it's a dead giveaway because they use the single in-unit injectors, and a dead giveaway for those is basically just grease dripping off the machine and super greasy components. So it's just a matter of then getting the setting for that injector, or pulling the old one out and checking the measurement and comparing it and matching it up. So yeah, that's the grease system on those. So electrical circuits in these, they're notoriously difficult, but again, if you could read schematics, this is where I probably really shone at learning to read schematics, was working on Liebherr electrical systems. Going to any other schematic now is rather easy compared to these. They're really good schematics, but the systems in them are very complicated, so they separate the men from the boys, these ones. But to start off with, I'll start in the cab, right? So we have our FSG board, basically the logic for the attachment and tramming. Basically you have your joysticks, U21, U22, and then your tramming pedals. So basically the FSG board is what interprets an analog input to a digital, analog input to analog output, right? So basically you get your inputs from your joysticks, and it will then determine the logic in the FSG board and then send it down to your proportional controls, so our Ys and our YRs, right? And then this is how they split the flow up. So they basically, you're using boom up, full rack, 4 pumps, 4 valve banks will engage boom up spools, but then when you go and pull the breakout implement, that board is what determines the logic and what logic goes, what valve banks to power up, right? So it's a super clever system for a 30-year-old machine. It's outstanding technology, and that's why it is still relevant today, because they still utilize a lot of the same principles in the more modern diggers, sorry. So yeah, it's really takes your head a long time to get your head around it. And also up there on that FSG board is what they utilize for soft stop circuit, right? So what they do to soften the blow for bucket out and stick in and out. They don't have boom or bucket in soft stops. They basically activate proxies down on the implement itself, and then they'll drop valve banks out as that implement gets close to the end of stroke to soften the blow and stop banging and clanging, right? So pretty nifty circuit, but can bring you unstuck if you get a slow implement. They have lights on everything, and you can see what pretty quickly if you have if they're complaining about slow stick, for example, you can go there straight away, disconnect your soft stops and see if that rectifies the issue, because it might be only utilizing 2 valve banks for stick, and basically by dropping the connector for those soft stops out, you can work out pretty quickly if it's a proportional issue, right? Then in there as well too, in the same cabinet, you have what is a 1018 card. Now they called this an amplifier card, and thanks to Coxie for this one. Coxie taught me all about these. Was basically what the 1018 card does is takes load off your FSG board, because that FSG board can only put out so much power to the proportionals, and then I've seen at times where people have run wires directly from Ys and YRs up to the FSG board, and then the FSG board starts wigging out and causing slow hydraulic issues, right? So the 1018 card, some of the proportional controls like the Ys and YRs will go via our 1018 card, and this will basically take the load off that FSG board, because it is very, it's putting out milliamps. It doesn't take much to draw a heap of power off it, right? So that 1018 also is an amplifier card, which has our slew controls for our Y151s and 55s housed in there as well too. So they also utilize a pretty common board across the fleet, right, which is a 1008 card. It's called an ad board, and they basically, it's a common board for relays, where it has a few relays housed in it, and they run various circuits like ladders, alternators, things like that off it, and it's just a common board. So when you get to those, you're looking for the inputs and then the outputs, and then you check your sensor that it's reading off, right? So that's common across the Liebherrs. It's a really nifty circuit, so they use that for hydraulic shut-off, fuel shut-off, alternators and things like that. So if you know one, you know them all, right? Basically then moving out of the cab, we have the 1008 cabinet, right? And this is just like an auxiliary cabinet. We have ladder 1008 board up in there, and we have a heap of relays and things like that for auxiliary circuits in there as well too. So again, moving to the power packs, right? We have a E101 cabinet and a 101 and 102 cabinet, right, for each engine. So engine 1, 101, engine 2, 102. They have add boards in there, the hydraulic shut-off tap, fuel shut-off tap, alternator in there as well too. They use a lot of common terminology, right? So across the fleets, obviously they have the standard electrical stuff, K15, K31, KL31, things like that. So common terminology, but they use for their relays. So common pretty much from what I've seen across the fleet, K16s are what your start relays are. So you can bridge your start relays up there and start the motor remotely from up there, and individually test your starters from up there, right? So you can power one up and then power the other up. We also have K19s. So K19s what drops out your buzz bars, which contain all your circuit breakers, so that when you hit an E-stop, boom, drops the power away from your K19, so then you have no power going to anything, right? So down in our battery box, we have our K11, which is for the auxiliary batteries. And we also have some, I think they're 400 amp fuses, but you know, they do tend to pop, and I have seen at times where they'll put bigger fuses in there, but it's a matter of keeping those buzz bars down in the battery box clean. There's a couple of common connectors as well too, up under the cab. I think it's X415s, like I've had those, the ones up under the cab there come loose, so really good to keep an eye on those cab mounts, because the cab mounts will wear out on those and then cause those to come loose. I've had that a few times. So that's our electrical circuit. It's not everything, but it is a very impressive circuit, and those are some of the main components in it, right? So that FSG board, I reckon, is money. It's a fantastic bit of kit. So over the years of working on these diggers, I've had quite a few impressive failures, and they are really challenging to diagnose at times, especially when it comes to the electrical systems. But once you sort of learn the common way that Liebherr do things, you know, and you learn how to interpret their schematics, you know, it makes life a lot easier. I'm not saying that I'm a professional at it, but I definitely can get in and nut my way around them. So some of the impressive failure videos that you've probably already seen on the Instagram shorts or reels is pin wear. So it was a stage there where we ran through a heap of pins and bushes on those excavators, basically changed over grease, and for whatever reason, I don't know if it was to do with that, the rep said it wasn't, but yeah, basically we had a heap of pin failures that were quite impressive, and dead giveaway on those Liebherr 996s. They put and in Liebherr really, they put a grease ring around the O-ring. When they snap, it's really good to keep an eye on them with your inspections, and if you see one that's snapped, generally it's a dead giveaway that you've got excessive movement in that pin, right? So then next we had the bucket cylinder failure. Pretty good video of a lot of metal contamination in our returns. So basically got called up to a drifting bucket, and basically they when I got down there, got the temp gun out and said, yeah, basically temp the cylinder, and yeah, it was I think it was about 8 degrees hotter than the other one. Then it was basically, you know, I got it to hold it over relief on bucket, the operator, and you could literally hear the oil screaming past it. So pretty confident that it was a cylinder. Then went and confirmed by removing the returns to see how bad it was, and we had to do a full flush on that circuit. So yeah, that was an expensive one, and you know, highly recommend with those sort of failures you change out both cylinders and flush both circuits. So another pointer with cylinder failures, go and drop the bottom line off your hydraulic coolers, because most of the time if you've got a really bad failure, including metal in it, you're going to have a lot of metal build up in the bottom of those coolers, right? So again, secondary relief failure, the snapped cartridge. That one was a drifting implement as well too. That was quite common, and what I put it down to was a lot of times there you wouldn't have flowed secondaries. So basically people would just do the secondary in until it touches and then wind it out at half a turn, right? So then, you know, they're never set the same, they never flowed the same. So the secondaries was quite common, you could nearly pick it. So most of the time there I would either set the secondaries on one of the excavators that was parked up in the main relief position, you know, or then just literally go and flow them, but you never really had the time there at times. But a lot of the times now that's eliminated by the secondary kits that you get, the tune in a box I like to call them. So we had a stick in fault, or stick out, it would get stuck in stick out, and this was going on for a couple of weeks. Basically I went away and studied the circuit fairly in depth and got stuck one day, because it'd never get stuck while we were there. It always seemed to come good, and then turned out to be I was, you know, got the operator to hold the function for stick, and then I was going through wiggling harnesses and the connector up under the cab, X415 I believe it is, it basically then faulted and dropped the wires away from it, so it was a loose connector, that one. So yeah, it's really important to keep an eye on the cab mounts on those 996s, because yeah, you will get faults like that from loose cab mounts. I've also had from loose cab mounts that the windows are moving or something like that. It was a weird one, but it was the cab mounts that were smoked in it. So then again, main pump 2 on excavator 8, we had a contam go, and then basically pulled the contam and it was like, oh, there's a bit of metal in that, and then pulled the high pressure screens and the case returns for that pump, and the case returns was just full of brass and full of metal. So yeah, that was a, you know, pretty good one that we picked up pretty quickly, but that's why they put returns there, not just for service to piss you off, but just to utilise as evidence when you are trying to diagnose something. So some people might have wiped that contam and sent it back to work, but I went and pulled the HP screens, discovered a heap of brass, and then discovered a heap of metal and material in the return filters. So you use them to diagnose, right? So to give you extra justification for changing that pump out, because some people will just wipe it off and yeah, we'll see how it goes, and then the next thing you know, I've heard of main pumps failing and dropping the internals down into the suctions and just completely smoking everything. Now, don't actually have a video of this, but we had a closed loop circuit failure in one of the excavators. Basically they done a shutdown, put a new swing pump in it, sent it back to work, and I got a video of a swing pump that had exploded. And then after that, they didn't flush the circuit correctly, from what I can gather. Came in again when I came back to work. They said basically the 2 rear slew motors are getting hot. We did a change out of those, and then it was still slow to slew. And it went on for quite a while. Just because the metal kept travelling through the circuit, it smoked the front swing motors then, because obviously closed loop, everything's connected, and then it smoked the pump on Power Pack 2 again. So super important when you're dealing with closed loop, basically get in and clean things out. Like a lot of places will do replacement hose kits so you don't have to bud gun them, because basically, yeah, it's closed loop, it's replenishing oil to flush and cool that system and lubricate it. So you're only, if you don't go and change and bud gun all your lines, you're basically going to have metal in that circuit that's never going to get out. It's not like a conventional circuit where it goes suction to pump to valve bank attachment and then back via returns. It basically will stay in that system and just keep destroying things. So hopefully you found this video entertaining, whether you're a mechanic, operator, or you're just an enthusiast and you love machinery. You know, the 996s are notoriously difficult to work on. From what I can gather from the operators, they're fantastic to operate, and they are a super unique bit of kit. You know, they're very tight to work on, and for a 30-year-old machine, they're still going hard to this day, and that's why I have it as the logo of my business. I fell in love with these 996s. It would have been nine plus years ago where I started working on them, and basically from doing shutdowns on them to then leading into being on crew out at Solomon FMG working on them, and then again at MacArthur River I spent a good couple of years there working on their 996s and really got to intimately know them and have a lot of respect for them. So yeah, there is a lot of difficult jobs on them, but yeah, I hope you have enjoyed that. Thank you for the support on the videos. So smash the like button, leave me a comment, leave me a question. I love it. And I'll keep these videos rolling. Cheers.